Hello, ma'am. The topic of our ADC IA-2 is DSBSC generation methods presented by Yatendra Yadav and my classmate Smit Bengare. So he will explain what is DSBSC. You can go, Smit.
So DSBSC stands for double sideband suppressed carrier. It is a modulation technique where both sidebands of the modulated signal are transmitted, and but the carrier signal is suppressed. So in this simplifies that the transmission process saves bandwidth because only the sidebands which contain the information are sent. So it's like sending a letter without the envelope. The content in the envelope is still there, but the carrier, which is the envelope, is discarded. So there are two forms of DSBSC. One is the DSB generation using ring modulator, and the second is DSBSC generation using balanced modulator. DSBSC generation using ring modulator. So the DSB, the ring modulator construction contains two methods. So one is the diode arrangement, and the second is the balanced configuration. So the diode arrangement in this arrangement, basically there are four diodes connected in a ring configuration. So diodes D1 and D3, as you can see, are connected in series, forming one pair, and diodes D2 and D4 are connected in series, forming other pair. And the cathode of the D1 is connected to anode of D2, and the cathode of D3 is connected to the anode of D4. And the remaining nodes of the diodes are connected together to form the output. So, moving forward to the operations. So, when the input signal have the same polarity, like both positive or both negative, one pair of the diodes become forward biased while the other pair becomes reverse biased. As a result, the signal from
Smith, your voice is not clear. Can you speak again?
as a result, okay, the signal from the forward biased diodes passes through the output, while the signal from the reverse biased diodes is blocked. When the input signals have opposite polarities, like one positive and one negative, then the conducting non-conducting roles of the diode pairs are switched. This alternating conduction patterns results in the modulation of the input signals, producing DSP as a signal at the output. The output signal that is extracted from the ring modulator contains components at the sum and different frequencies. These effectively modulates the input signal onto the carrier signal, allowing the transmission or further processing of the modulated signal. Moving forward to the advantages and disadvantages. So the advantages of using a ring modulator for DSB-SC generation is effective use of power due to suppressed carrier transmission. Second is low susceptibility to noise and interference. Third is high linearity, suitable for analog modulation applications. So the disadvantages are requires precise carrier and modulating signal synchronization. Second is complex circuitry leading to high implementation cost. And third is susceptible to phase and amplitude imbalances requiring careful calibration. So the second method DSBSC generation has is balanced modulator, and I would like to hand over it to Yatendra Yadav. He'll explain it to you.
Thank you, Smith. In balance modulation technique, both the upper and lower sideband are transmitted while the carrier is suppressed. So in a DSBSC balance modulator, it is made by matched transistor pairs of FET which are arranged in balanced configuration. The input and carrier signals are applied to these transistor pair based on base or gate. The collector or drain terminals of the transistor pair are connected in a balanced setup, often to load a resistor or transformer. The balance setup ensures that the resulting modulated output contains only the sum and difference frequency of the input and the carrier signals. Thus, the balance modulator produces a clean modulated signal with just the desired sideband carrying the information of effective, cancelling out the carrier and unwanted sideband components. Can you take the next slide? Moving on to the operations, in DSBSC, the input signal and the carrier signal activate and deactivate the transistor pair alternately based on their varying amplitude. This alternate effectively multiplies the input and the carrier signal, resulting in the sum and difference frequency component. Through carefully balancing of transistor pair, unwanted carrier and sideband components are eliminated, leaving only the intended modulated output signal. Moving on to advantages and disadvantages of balanced modulator, it is advantages is effective use of power due to suppressed carrier signals, low distortion in output, and effective transmission of large amount of information. The disadvantages comprises of required precise balance adjustment for optimal performance, susceptible to phase and amplitude imbalance, a more complex circuitry compared to the modulation techniques. In conclusion, the choice of modulation technique depends on the factors such as application requirements, desired performance, characteristics, and available resources. You can explore both of these by their strength and limitation of each techniques, engineers and design, and based on that assumption, you can choose what is effective for you and resilience for the modulation system.
Now we would like to show you the code and the output.
All right, so let's break down the MATLAB code for DSBSC generation step by step. So first we can see the setting parameters which are the variable is set up by fs, fc, t, ac, am and fm, where fs is a sampling frequency which determine how often we measure the signal. Fc is the frequency of the carrier signal. T is the time vector which represents the duration of our signal, and AC is the amplitude of the carrier signal, which is 1. AM is the amplitude of the message signal, and FM is the frequency of the message signal, which carries the information we want to emit. So moving on, Smith, you can take over from here.
So now I'll explain you how the signals would be generated. So we will create the message signal M using a simple sine wave with frequency FM, and similarly we'll create the carrier signal C also using a sine wave with frequency FC. So for DSBFC modulation, we will use two methods like I said in the PPT before, ring modulator and balanced modulator. So if for ring modulator, we'll multiply the message signal M with the carrier signal C. This process mixes the message signal with the carrier one. And for balanced modulator, we multiply the message signal M with both the cosine as well as the sine components of the carrier signal C. Then we subtract one from the other. This process is also called as Gilbert cell modulation. And for plotting, we plot the message signal, carrier signal, and the modulated signals. The first subplot shows the message signal. The second subplot is showing the carrier signal. And the third subplot shows the ring modulated signal in red and the balance modulated signal in blue. Can you show the output?
Yes, yes.
So as you can see in the output, for the ring modulator, it is shown in a red color, and for balance modulator, it is shown in blue color. The output of the ring modulator is the product of the message signal and the carrier signal, as I said before. So you'll see the original message signal riding on the top of the carrier. Since we are using a ring modulator, you'll see both positive and negative frequency components, resulting in double sideband modulation. And in case of balance modulator, the output of the balance modulator involves subtracting two terms. One where the message signal is multiplied by the cosine component of the carrier, and another where it is multiplied by the sine components. Uh, so can you conclude for the code, please?
Sure. Actually, this code essentially demonstrates how to perform DSBSC modulation using both ring modulator and a balance modulator in MATLAB. It's a way of combining message signal with a carrier signal to transmit information effectively without any loss. So this is our ADC IA-2. Conclude here.